Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine y prime for each of the following. So we have to find the derivative of these three functions. So let's start with the first one, y equals tan of sin x. Now this is a composite function, so we'll have to use chain rule. So here the outer function is the tan function and the inner function is sin x. So as per the chain rule, we'll start with the derivative of the outer function. So the derivative of tan is secant square times the derivative of the inner function, and the derivative of sin x is cos x. Now we can rearrange the terms. So this should be the derivative of the first function. Now we can analyze the second function. Now the second function is also a composite function. So in this case, there is an outer function, the power -2, and then the expression in the parentheses or the brackets also is a composite function. So there is this outer function tan, and the inner function is x squared minus 1. So in this case, we'll have to use the chain rule twice. So let's start with the outermost function, the exponent -2. So we'll have to use power rule. So as per the power rule, we'll move the -2 exponent to the front and we'll subtract 1 from -2. Times the derivative of the inner function. Now the inner function is also a composite function, so we'll do the derivative in the next step. So in this step we'll just write it as then prime. So we'll do the derivative in the next step. So in the first part we can simplify the exponent. -2 minus 1 is -3. Times. Now we'll use chain rule again. So this expression has the outer function tan, and the derivative of tan is secant squared. Times the derivative of the inner function, and the inner function is x squared minus 1. So we'll have to use power rule to find the derivative. So the derivative of x squared is 2x, and the derivative of 1 is 0 because 1 is a constant. Now we can simplify this expression. Now in the last parentheses, 2x minus 0 is 2x, and we can multiply 2x by the -2 at the front, and that will make the whole term negative. So we get so this should be the final answer for the derivative of this second function. So now we can analyze this third function. Now in this third function, so there is a square on the tan. So the first thing is to change this expression to So the square is on tan. So that means this is a composite function with the outer function being the square function, and then the inner function is also a composite function with the outer function tan and the inner function cosine function. So we'll have to use the chain rule twice. So we'll start with the outer function, which is the exponent 2. So we'll have to use power rule for it. So as per the power rule, we'll move the 2 to the front and we'll subtract 1 from 2. Times the derivative of the inner function. Now since the inner function is a composite function, we'll find the derivative in the next step by using the chain rule again. So we'll just show in this step as now in the next step we can use chain rule again. So in the first part, so we can subtract the exponent. So 2 minus 1 is 1 and we don't write 1 as an exponent. So now we have to use the chain rule. So the outer function is tan and the derivative of tan is secant squared. Times the derivative of the inner function. The inner function is cos x and its derivative is minus sin x. Now we can multiply the terms. So negative sin x times 2 will make the whole term negative. So negative 2 sin x. So this should be the final answer for the derivative of the third function. So these are the steps you have to keep in mind to find the derivative of tricky trigonometry functions with tan ratio. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.